In this video, we're going to take a look at rationalizing the denominator. Now, what do we actually mean here by rationalizing the denominator? Well, all we mean here is that we want to get rid of any surds that are within the denominator. So if we take a look at this first example here, I don't want this root 6 in my denominator. We want to get rid of that. Okay, so what we'd do there is we'd rationalize the denominator. And same again here with this second example, we don't want this minus root 6 here. So again, we just rationalize the denominator. So how do we actually rationalize the denominator? Well, all we do here in this case, so there's two different types here. This first one is quite a straightforward example. The second example here is a little bit more complicated, so let's just start with this first one. So to get rid of something like this, what I call the simple case, well, all I need to do is actually just times by root 6. If I times by this surd again, okay, make sure we do this to the top and bottom, then what it does is it gets rid of the surd in the denominator, because remember what I'd get then is the square root of 36, which is equal to 6. So like we said, we times top and bottom here by root 6. So times top by root 6, the numerator. Do the same with the denominator. So what I'm going to get here then is 12 times root 6, which is 12 root 6. For the denominator, like we said, this would give me root 6 times root 6. So that's equal to root 36. And root 36, we know that simplifies to give us 6. So what I've got here is 12 root 6 over 6. And we can simplify this here. 12 root 6 divided by 6. Well, 12 divided by 6 would give me 2. So what I get then is 2 root 6. Okay? And that's our solution. That's the answer in its simplest form. Question done. Because make sure you do take the time here to simplify this. At this point here, this is technically rationalized. We have rationalized the denominator. There's no surds there, but it's not in its simplest form. Okay? So like we can see here, that's our solution in its simplest form. Now for this second one here, this is where things get a little bit more complicated. And the reason why is because we can't just times now by this surd again. And the reason for that is because we've got this 3 here. Okay, we've got another number with our surd. So what do we do to get rid of the surd here? Well, we need to make use of the difference of 2 squares. So what I times by here now is what we call the conjugate. So if our denominator is 3 minus root 6, we times by 3 plus root 6. Okay, this is what we're going to multiply the numerator and denominator by. So this is what we call the conjugate in this case. So it's the opposite sign. So this is the conjugate. So if that was 3 plus root 6 here, then we times by 3 minus root 6. If this was, say, 1 plus root 2, we'd multiply numerator and denominator by 1 minus root 2. Okay, so always multiply by the opposite sign. So if we do that here, times top and bottom by 3 plus root 6, by 3 plus root 6, do the same here, 3 plus root 6. So what I'm going to get now is a product here of 2 brackets. So if we write these out in full just so we can see everything clearly. In the numerator, we've got 3 plus root 6 times 3 plus root 6. So 3 plus root 6 squared. That's our numerator. For the denominator, we've got 3 minus root 6 times 3 plus root 6. So 3 minus root 6 times 3 plus root 6. Okay. And what I need to do now is just simplify or evaluate both of these products here, starting with the numerator, do the same with the denominator, and then we just want to cancel or simplify as we go. So 3 times 3 here, that would give me 9. 3 times root 6 would give me 3 root 6. Root 6 times 3 would again give me 3 root 6. And then finally, we've got root 6 times root 6, which we know would give root 36, which is equal to 6. Okay, so that's our numerator. We'll come back to simplify in a moment. Let's just evaluate the denominator. So again, we're going to expand here I'm using the method of FOIL, but any method to expandable brackets is fine. Now with this denominator, we can speed things up a little bit by noticing this is the difference of 2 squares. So all I actually need to do here is 3 times 3, which gives me 9. And then we do minus root 6 times positive root 6, which would give me minus 6. So just be careful with the signs there. We get minus 6 as opposed to positive 6. Okay. So what we need to do now is simplify the numerator, simplify the denominator, and then we can evaluate and hopefully get our answer in this form. So we finish this down here. So the numerator, I've got 9 plus 6, so that's 15. So that's fine. I've got a 3 root 6 plus 3 root 6. That would give me 6 root 6. Okay, so that's 6 root 6. That's my numerator. And for my denominator here, we've got 9 minus 6, which would give me 3. Okay, so we get 15 plus 6 root 6, over 3. Now we want the answer in the form a plus b root 6, where a and b are integers. So if a and b are integers, we need to evaluate here, or simplify this fraction. So essentially what this simplifies to is 15 over 3 plus 6 root 6 over 3. Okay, you don't need to show this step here, but that is essentially all we have here. So 15 over 3, that's 5. 15 divided by 3 gives me 5. And then 6 root 6 divided by 3, well, that would give me 2 root 6 there. And there we have it. That's our solution. And notice we've got it in this form here. So therefore, if we do it up here, a is this value here. That's 5, which is an integer. And b is this value here, which again is an integer, which is 2. So we know our answer looks good. And that is our solution there. Okay, so like you can see, nothing too bad, but you've got to make sure that you multiply through by the conjugate. Okay. So we've worked through a couple of examples together there. Now it's your turn. So pause the video here, have a go at these practice questions, and then we'll take a look in a moment at what you should have got. So hopefully you got an okay with these two practice questions. Let's take a look now at what you should have got. So for this first one here, I want to rationalize this. Now it doesn't explicitly say rationalize. It just says show that this expression here, or this fraction, simplifies to root 23. So the big clue that we need to rationalize here is that we've got a third in the denominator. And what we want to show is that it just simplifies to root 23. So at some point here, we do need to rationalize. Now, I think it makes sense here, before we do any rationalizing, just to clean up this numerator. Okay, so we can simplify this. And if you notice here, what I've actually got again is a difference of 2 squares. So you can expand the full expression using FOIL, but you don't need to. You can speed things up here by multiplying 5 by 5. So it would give me 25. And do the same with minus root 2 and positive root 2. So that would give me minus 2. Okay. So our numerator is 25 minus 2. And our denominator at this point is just what it is here. So that's root 23. Okay. So cleaning this up, we get 23 over root 23. Okay. So how do we show that this now simplifies to root 23? Well, the only thing that makes sense here at this point now is to rationalize the denominator. So this is just a third in the denominator. So all I need to do now is times the numerator and denominator by this third. Okay, so rationalizing. So rationalizing here. We're going to take our numerator and denominator and times by root 23. Times by root 23. Do the same with the denominator. So in my numerator here, what we're going to get is 23 lots of root 23. So that's 23 lots of root 23. And now in the denominator, we've got root 23 times root 23, and that will just give me 23 there. Okay. So what we've got here now is 23 root 23 over 23. So there's a lot of 23s, but we want to show that this just simplifies to root 23. And clearly at this point here, this does just simplify to root 23 because we can divide top and bottom here by 23. Okay. And all I get left with is root 23 there. Okay. As required. And that gives us our solution. So that's the solution to the first question. Let's take a look now at the final question. Now here we're asked to show that this fraction here can be expressed in this form. Now again, we have no denominator here. There's no thirds in the denominator. We don't have a denominator. So we know we need to rationalize at some point. Okay. So where do we begin? Well, we've got our numerator, we've got our denominator. We can go to rationalizing straight away because our numerator and denominator are both in their simplest form. But be careful here. This is 1 minus root 3. So we can't just multiply the numerator and denominator by root 3. We need to multiply it by the conjugate. We're going to times top and bottom here by 1 plus root 3. So 1 plus root 3. Okay. Do the same with the denominator now. 1 plus root 3. So what I'm going to get then, like we said before, for the previous type like we did on this page here, is we're going to get a product now of double brackets. So we're going to get 5 plus root 3 times 1 plus root 3. And this will all be over 1 minus root 3 times 1 plus root 3. 1 minus root 3 times 1 plus root 3. Okay. So Let's evaluate now our numerator and denominator here. So 5 plus root 3 times 1 plus root 3. Well, again, I'm going to expand this using FILE. So 5 times 1 would give me 5, so that's fine. 5 times root 3 would give me 5 root 3. So we get 5 root 3. Root 3 times 1, well, that would give me 1 lot of root 3, or just root 3. Now, it's up to you whether you write this as 1 root 3 or just root 3. Remember, if we just write root 3 here, that is 1 root 3. And then finally, root 3 times root 3, that gives me plus 3 there. Okay. So that's our numerator. We'll come back to simplify in a moment. The denominator now, notice here again, this is the difference of 2 squares. So we just need to do 1 times 1, which is 1. And then minus root 3 times positive root 3. And that gives me minus 3 there. So what have we got here now? Well, let's simplify the numerator first. So I've got 5 plus 3, which is 8. And then we've got 5 root 3 plus root 3. So take care here. This is 1 root 3. Adding them together, we get 6 root 3. Okay. So that's our numerator simplified. Do the same for the denominator. So 1 minus 3, that gives me minus 2. And all we need to do now is just simplify this. So 8 over minus 2, so that would give me minus 4. We get minus 4 there. And 6 root 3 over minus 2, and that's going to give me minus 3 root 3 there. Okay. And there we have it. So that's our solution. Notice here now we've got it in the correct form as well. So therefore we can identify the values of A and B. So A is minus 4 and B is minus 3 here. Okay. And remember, an integer is just a whole number. It can be positive and it can be negative. So we know our solution looks good there. Okay. And there we have it. So that brings us to the end of this video. In the next video, we're going to take a look at exam revision for surds.